about direct variation is it has to do with items that are proportional. Everything that we graphed on the practice today, when you came down to the interpretation, you had something per hour, right? Per hour being 1. So for every change in the x, the same amount, the change was the same every time for the y. Do we agree with that? Okay? And you came up with a lot of formulas that said y, like the first one said y equals, maybe this was the second one, I don't know. One of them said y equals 5x though, right? That was the second one. The first one said y equals 9x. Okay, 9h because it was the number of hours, right? Okay? And it kind of threw you because there wasn't anything else. There was no y-intercept that had to be identified. What did you notice about the y-intercept in both of these? Because they're proportional. What was the y-intercept in both of them? 0. So every time you see a graph, if the y-intercept is 0, you know that the two items are proportional. They're in direct variation. Proportional, this doesn't go yet. I'll tell you what I want on the proportional. Yes. Shall I write this down? Is it pro or poor? Proportional. It's pro, isn't it?
It's pro.
Okay, that one throws me. Proportional equals direct variation. They're the same thing. They are the same thing. So if somebody asks you if the data that you have graphed is proportional and you already know it's got a direct variation, it's the same thing. Okay? Direct variation is a term that you're going to hear on your assessment. Okay? That's something I know you're going to be hearing. By definition, what direct variation is, we know the formula. This you want on that is nothing more than y equals mx. The formula is important to you. You want to make sure that on direct variation that you have the formula written down. Okay? We're working on number 3. Yesterday we worked on, yeah, and that was kind of kind of messed up. Trust me on that one. Sorry. Well, I was kind of lost a little bit.
I thought I messed up and I was like,
No, you're
hey,
fine.
Your brain was still waking.
My brain was. Okay, direct variation, the formula will always be y equals mx. Because you know the y-intercept is always 0. Okay? And you might just want to make that note for yourself. Y-intercept always 0. Always 0 in a direct variation or a proportional graph when x and y are proportional. And that is the definition. The definition for direct variation x and y are proportional. Or two quantities. X and y are the variables, but this technically is the two quantities. Okay? The amount of money that Reagan makes babysitting is directly proportional to the number of hours she babysits. The amount of money that it costs you to rent a moped on Hawaii, on the island of Hawaii, is directly proportional to how many hours you're going to have it. Renting a tuxedo and its cost is not directly proportional. Because you might rent a tuxedo and keep it for 3 days. the cost of the tuxedo is the same whether you rent it for 1 hour or you rent it for 24 hours. It doesn't matter. So they're not proportional. You see the difference? That just has a set price. This is what it's going to cost you. When I go buy a gallon of gas, it's not really that proportional to how far I'm going to go. It has nothing to do with it. It's just that's a set fee. Does that make sense? The difference between what's proportional and what's not? Okay? The graph is always going to be a line. Let's see. Okay, I said it, but we're going to go ahead and write it. The graph is a line that will pass through the point of origin, always. That point of origin is always 0, 0. Okay? It will always pass through at that point. Okay? Now, what if I told you, let me give you this, and we're going to work a couple. What if I tell you, what if I tell you I have a set of points, and I say, my points are 2, 6, my points are 2, 6, they are proportional, they have a direct proportion, they're a direct variation. What is M? And I say find the slope. But I'm only giving you one set of points. Can you find the slope? What is the slope in this case?
3.
3. How do you know that?
I just divided by 2 and broke it down into half. Got
Okay.
3.
Okay, Wesley?
Because it's in line with 0, 0.
Because it's in line with 0, 0. You're both correct. What if we said the formula looks like this? Y equals mx, right? So can I substitute the values for x and y into the formula that I know it has to fit? Because I know it's proportional. I know it has direct variation. So if you substitute in, and you substitute 6 equals 2x, okay, then x, wait a minute, stop that. 6 equals m times 2. I'll just go ahead and leave it the way it was written there. And I divide both sides by 2, m has to equal 3. Okay? So you've been given a set of points, and you've been given the slope, or you've just been given the set of points and you had to find the slope. If you had, what if I told you that, what if I said x equals 4, and we're going to say m equals, if I said m equals 3, could you find the value of y? Can we use that same data to find y? Aaron?
You just like do the opposite multiply.
Okay. Can I plug it into the formula? Go back to the formula. And so y is out there by itself, and y is going to have to equal 4 times 3, isn't it? So y has to be 12. Yes, you just multiply them together. Okay? Using what you know about the formula to find the missing pieces. Okay? That you need to be able to do. Okay? Anything else I need to make sure that you got? That's what I'm working for. You ready for an assignment?
Yes.
Yeah.
Because with what you've already done and with getting this down, I know you're gonna be fine. So, let me. There's the assignment right there. You go into the textbook today. Textbook page 162, 163. 1 through 10 and number 12.